So this is the solution when we have one pair of first order linear differential equations. So we are having x prime and y prime. It's just one pair. But let's say if there are like n equations, right? N differential equations, then you can just continue on with like plus e to the lambda 3t times v3 and so on. If you're having n, you go up to e to the lambda nt times vn. It's going to be a general solution. So you can find lambda 1 and lambda 2, and then you can also find the corresponding eigenvector, and you would be done with this. Now, if you notice something, right, the general form which I have given you is in a linear method, right? But if you noticed here, it was in a vector method. So what happened here? Okay, so it is still of that form, but we're just not able to see it clearly. This vector is going to have two components, say, let's say v11 and v12, right? And hence my left hand side is still going to be x prime and y prime, and I'm just solving for that. So it's keeping x prime and y prime as it is and just evaluating the ax side. So when I get the solution, I've transformed this into x of t and y of t to get some value, and that would be this one. So when I'm expanding it, my answer would be x of t, y of t is equal to e to the lambda 1t times v11, e to the lambda 1t times v12 plus, and then it just goes on. Okay, so my x of t would be all the components on the top side or the upper side of the vectors, and my y of t would be the sum of all the components on the lower side of the vector of the eigenvectors. So that's how my solution is going to be formed. This is why eigenvectors are very important, because over here for a 2 by 2 we can do this way. So think about it. If we extend our analysis to an n by n matrix, right? If you're having more than a 2 by 2 equation, we could still proceed with the eigenvalue and eigenvector method, and we can get a good solution for it. So the next topic within this is, what is the primary use of it? So if you look about it, the first order differential equations, we already have three good ways to solve it, pretty easy ways to solve it. But now when we are moving to a second order differential equation, and if we have only one equation, we can still use the matrix method to solve it, because we cannot use the separation of variables method over there, right? Because it would involve multiple integrations, and we don't know what you are going to deal with y prime, because there's also going to be y double prime. So over there, we're going to bring in our matrix method again. So I'm just going to start off the example in this video, and I will continue the explanation in the next video. So let's just say, for example, we have a second order differential equation that looks something like this: u double prime plus 0.25 u prime plus 2u is equal to 3 sine t. So the question asks you to solve the differential equation, but the primary step that's involved is setting up the differential equation. Okay, this is going to involve a weird term. I'll just explain that in a minute. But let's just set up the matrices first. Okay, so over here we are just going to consider u prime is equal to v, right? So what happens to v prime? V prime would just be u double prime. This would simplify the way of solving it for us. So we can change our matrix to again v and v prime, right? And we're going to have a matrix over here times we're going to have another vector over here plus something else. Okay. If it's v and v prime, this should be integral of v and then just v. The integral of v would be integral of u prime, so that's u. So I'm going to have u on top and then v at the bottom, right? Because this equation is going to change to v prime plus 0.25v plus 2u is equal to 3 sine t. Or this term could also be 0.25 u prime, right? So we have to stick to one thing. So I'm going to use u and v. So I'm completely rejecting u prime, okay, because I'm just using v. So my equation is just going to be v prime plus 0.25v plus 2u. So what I'm doing is I need I have v over here. So to get v on that side, I'll just have to do 0 times u plus 1 times v, right? And I'm gonna have a 0 over there. So only then it's gonna give me v is equal to v to balance things out on both sides. But when I have v prime, right? So this is equal to 3 sine t. So when I'm having v prime, so v prime would be 3 sine t minus 0.25v minus 2u. Now this is what I have to set up, right? So how many times u are there in the equation? There's going to be minus 2, right? So I'm going to put minus 2 here and minus 0.25v. So I'm bringing that also in here. And I have a term left out, that's 3 sine t. So luckily we have added this vector where 3 sine t can fit in, right? So this would be my matrix to solve. And I'll tell you how to solve this in the next video. Okay, thanks for watching.